Hey y'all, Miss Hantler here. Today we'll be going over rate of change. That's all I got. Here, you get it now.
Okay, hey y'all. Yes, today we're going over rate of change. And we have a guest teacher. Hi. Yes. So, a few vocabulary words. Independent variable. The independent variable is also the input, the x value. That is going to be, like in science, your independent variable is the one that you can control. So the independent variable. Dependent variable is the output, or the y values. That's going to be on the y-axis. Independent is going to be on the x-axis. Dependent is going to be on the y-axis. And then rate of change, that's the whole purpose of today. The rate of change is a relationship between two quantities that are changing, hence change. The way we find the rate of change is we need to find the change and the dependent. This triangle is called a delta, and it means a change. So we're going to find the change in the dependent over the change in the independent. And the way you find a change is you're going to subtract. You're going to subtract. So if you have your average is a 92 and then your average is a 97, it changed by 5 points because you subtracted 97 minus 92. So it changed 5 points. So when you find the change, you're going to subtract.
All right. Only other thing to add, independent and dependent variable is your description or the title of your x-axis and the title of your y-axis. So those are words that you need to write down.
All right, so you're going to title your axes. All right, so example 1, we have a graph. And this graph is the time in seconds. So this would be your independent variable. This is the x-axis. The time in seconds it takes to get the depth right here. This is your dependent variable, the depth in centimeters of a bathtub filling up with water. So we're filling up a bathtub with water. From 10 seconds to 70 seconds, the water is filling up the depth of the bathtub.
All right, so let's talk about what's happening in our graph. This is 0 seconds because this is our origin. So at 0 seconds, we start filling up our bathtub. So you see my line is increasing. As my time increases, my depth increases. And this goes from 0 to 30 seconds. Then from 30 seconds to 50 seconds, I have a straight line, which means that we're not adding any more water at this time. And then from 50 seconds to 60 seconds, we start filling the tub up again. And then from 60 to 70, for some reason, we let the water out. Now we can assume that maybe the tub got too full, so we had to let the water down. All right, so the question is, what is the independent variable? Ms. Hentler already went over that. That's your x-axis, which is labeled time. What is the dependent variable? That's the depth of your water, or the height that your water is in the tub. Now, what is happening from 0 to 30 seconds? This is where we find our rate of change. So we do our dependent over independent. And our dependent variable from 0 to 30 seconds, at 30 seconds we stop at 60. And 0 seconds we had no water in the tub. So the change is 60 minus 0 over 30 minus 0, which is 60 over 30. So the way we would read this is our rate of change is 60 centimeters every 30 seconds.
And this right here from 0 to 30, you can see the line is increasing because Ms. Barnes just talked about it going up in a positive direction. So it's increasing, which means our rate should be positive. That should make sense to you. If you're filling water up, the longer the water goes in, the higher the depth is going to be.
All right, number 4, what happens from 30 to 50 seconds? So this is 30 seconds and this is 50 seconds. Well, we can look at our rate of change to describe what's happening. At 50 seconds, our water is at 45, and at 30 seconds, our water is at 45. And the time is 50 minus 30. 45 minus 45 is 0, and that would be 20. So our rate of change is actually 0. There's nothing happening here. We talked about that the tub is not being filled up. So there's a 0 rate of change. It's 0 centimeters every 20 seconds in this time interval.
Right. So not the entire time of the tub. He or she must have turned the water on and then stopped, turned the water off, and then looked at the level and then said, okay, I need some more water, so then they turned the water back on again. This question says, what happens after 60 seconds? So you come over here at 60 seconds, and it's the very top. So it must have reached its maximum of some sort. Either the person said, okay, that's enough water, or maybe it got to the top and it started overflowing, but for some reason the water stopped, and then after 60 seconds it started going down. So this part of our graph is decreasing because it's going down. And so the rate after this would need to be negative. So when we look at the change from 60, should I just go 60 to 70? All right, so that's 75 centimeters, and this is 90 centimeters. So my rate of change right here would be 75 minus 90. If you notice, when Miss Barnes was subtracting, she always started with the farthest one out and subtracted back. So she did 60 minus 0, and then she did 45 minus 45. So this would be 75 minus 90. And 70 seconds minus 60 seconds. That would be a negative 15 over 10, which means we are losing negative 15 centimeters every 10 seconds in this interval from 60 seconds to 70 seconds. So my rate of change is a negative centimeter drop because we're losing water. Let's say they pull the plug and the water is draining.
So when you're describing, if we ask you in context to describe what's happening with the rate of change, anytime your rate of change is negative, you have to describe that there's some sort of decrease. So we don't have a negative length. What we have is a decrease of 15 centimeters every 10 seconds.
All right, and question number 6 is, what's the rate of change from 50 to 70? So from 50 to 70, right here,
this is at 45.
45 to 70 is at 75. So our graph is filling and then starts to lose.
But if we find the rate of change, it's 75 minus 45 over 70 seconds minus 50 seconds. And 70 minus 45 is 30 centimeters over 20 seconds. So even though we're filling and losing, there is a 30 centimeter change from 50 seconds to 70 seconds in a 20-second period. We're not really describing if it's increasing or decreasing. We're just talking about the amount of water that has come in and out of the tub.
So it's increasing more and then decreasing a little bit. So overall, from here to here, it's got a change of 30. All right. So example 2. After having babies, Mrs. Hantla, Mrs. Barnes, and Ms. Schuler are trying to lose that baby weight. You got to get it off. In 5 months, they lose 12, 15, and 10 pounds respectively. So when you see the word respectively, that means in order. So since Ms. Hantla was listed first, that's 12 pounds. Ms. Barnes would be 15, and Ms. Schuler would be 10. What is their rate of change per month? So before we begin, we need to talk about independent and dependent variables. So independent variables are going to be your x values, your input. Dependent is going to be your output. So in this situation, what kind of has to happen first? What's going to be that independent variable? And
It's going to be your month.
month is going to be your independent, because depending, the month is going to give you the amount of weight you've lost. So in month 1, we lose a little bit. In month 5, we lose more. The dependent variable is going to be the weight that we have lost. So this is talking about the amount of weight that we have lost.
Alright, and again, if you're struggling with independent, it's the thing that you can't change. Me and Miss Hantler and Miss Schuler have no control over the amount of time that passes by, but we will have a little control on how much weight we lose depending on what we do to work out.
So to find Miss Hantler's rate of change, I would need to take dependent over independent, the change in dependent over the change in independent. So I know it's 5 months because I said in the problem 5 months. And I have lost 12 pounds. So my amount of weight is dependent, so 12 pounds over 5 months. Okay, my marker side. 12 pounds and 5 months. So that is my rate of change. That means in 5 months I've changed 12 pounds. Yeah.
Alright, and so Miss Barnes, apparently I've lost 15. I don't know if you guys can tell, but I lost 15 pounds in 5 months. So my rate of change is 15 over 5.
And then Miss Schuler just recently had her baby, so she's lost 10 pounds in 5 months. So that is her rate of change. So in context, we're talking about amount of weight lost. So our rate of change doesn't need to be negative because we are losing this weight. If we talked about how much we weighed, like if we talked about how much we actually weigh, then that number would decrease because we'd start and then we'd lose and lose and lose. If this was a graph, our independent would be the months. So months 1, 2, 3, 4, and 5. And this would be our weight lost. So as the months went on, our weight loss increased. So that's why our rate of change is positive, even though we're losing weight. Let me check the time. Okay, we're at 12.
Alright, example 3. Below is the data of our baby's weight gain. So we have a table where we have week 1 or the weeks and the amount of weight that the babies are gaining. So the question is, what is your independent variable? Well, again, time is something that we can't control. Once we had our babies, they are going to get older. So weeks are your independent variable. And weight is what is actually changing. So this is your dependent variable. So Ms. Hannah asks us to find the rate of change between week 1 and week 3. So at week 3, the baby weighed 11 pounds. And week 1, they weighed 9 pounds. So you're going to do 11 minus 9. And then you're going to subtract the time, which is 3 minus 1. 11 minus 9 is 2. And 3 minus 1 is 2. So if we just looked at this ratio, it's saying that the weight change was 2 pounds every 2 weeks. We could simplify that, which would still be the same thing as they lost 1 pound every 1 week.
Alright, so this next one says the rate of change from weeks 3 to 6. So again, we are going to subtract. At week 6, our baby weighed 14, minus week 3, which is 11. So it changed from 14 and 11. Then we subtract 6 minus 3 because those are the weeks we're talking about. 14 minus 11 is 3. 6 minus 3 is 3. And then this means our rate of change was 3 pounds in 3 weeks. 3 pounds gained in the interval of 3 weeks. We could reduce it again to 1 pound every 1 week for this interval, which is also the same interval as 1 to 3 weeks. So this looks like our babies are consistently gaining weight. 1 pound 1 week. 1 pound 1 week.
Alright, so from week 1 to week 10, our babies weighed 15 pounds. We're going to do 15 because it was the weight at week 10, minus 9 because that's the weight at week 1. And then we're going to do 10 minus 1. So 15 minus 9 is 6, and 10 minus 1 is 9. So from week 1 to week 10, our babies gain 6 pounds every 9 weeks. You can reduce that and find the average rate of change, which would be 2 pounds every 3 weeks.
And y'all are about to come back to class. So, this example right here is a question about lemonade sales. Here's a table. These are the months that we sold lemonade, and this is the money that we made selling lemonade. So you're going to use this as month 1, 2, 3, 4, and 5. And then these are the lemonade sales. Your input, your X values, your output, your Y values. So we want you to answer these questions, independent, dependent, what month did you make the most, and then your rate of change and rate of change.
From May to June and from August to September. And then answer the question, why are the rate of change, why is this one negative and why is this one positive?
And we're going to go over this in class.
See you later.